Hey everyone! The book that I have for you guys today is an information or nonfiction book called Grand Canyon by Jason Chin. This read aloud is dedicated to Allie. Now, I may not read all of the information on every page. I'll read the main narrative. And if you want to go back and if you want to pause each page to read the rest of the information on the page yourself or have an adult read it, you can go ahead and do that. All right, here we go. Here is a map of Grand Canyon National Park in Arizona. For Maeve. Rivers carve canyons. When they cut down into the earth, canyons grow deeper. As weathering and erosion break apart their walls, canyons grow wider. Over time, rivers wash all of the eroded material away. These processes have been at work for millions of years, relentlessly excavating the mighty gorge known as Grand Canyon by Jason Chin. Grand Canyon is one of the largest canyons in the world. It is 277 miles long, as much as 18 miles wide, and more than a mile deep. But it's much more than just a big hole in the ground. It's home to an astonishing variety of plants and animals. The canyon is much hotter and drier at the bottom than at the top. Because of this, different groups of plants and animals, or ecological communities, are found at different elevations in the canyon. The hottest part of the canyon is at the very bottom, a 1,000-foot deep chasm called the Inner Gorge. The Inner Gorge may be the hottest part of the canyon, but there are oases in this desert. Here are the ecological communities in Grand Canyon. Elevations are approximate. The Boreal Forest, Ponderosa Pine Forest, Pinyon Jupiter Woodland, Desert Scrub, and the Riparian. Creeks bring life-giving water into the gorge, and a wide variety of species live along their banks, including frogs, dragonflies, mule deer, and the endangered southwestern willow flycatcher. Many of these creatures are permanent residents that rely on running water for survival, while others are visitors drawn here by their thirst. Eventually, every creek in the canyon flows into the largest stream of all, the Colorado River. The Colorado runs the entire length of Grand Canyon, continually washing sediment away and slowly deepening its channel. It's been cutting into the land for around 5 million years, slicing through layer after layer of rock. Today, it is cutting into the Vishnu basement rocks. These rocks are part of the continental basement, the bottommost layer of rock on the continent. Here you can see the different rock layers in Grand Canyon: the Kaibab Formation, Toroweap Formation, Coconino Sandstone, Hermit Formation, Supai Group, the Surprise Canyon Formation right here in between, the Red Wall Limestone, the Temple Butte Formation, Muav Limestone is here. Here's the Bright Angel Shale, the Top Heats Sandstone here, the Grand Canyon Supergroup here, the Vishnu basement rocks are down here. Here's the Colorado River, and this is the Inner Gorge. The basement rocks are the oldest in the canyon, as much as 1.84 billion years old. Many younger rock layers are stacked on top of them. If you hike out of the canyon, you'll pass younger and younger layers as you climb, as if walking up through time. Above the basement layer, you'll reach the Grand Canyon Supergroup. Here you may find ripple marks, right here, preserved in the stone. Clues like these tell us what this place was like when the rock formed. They are like windows to the past. This is Grand Canyon, 1.2 billion years ago, when the only living things on Earth were microbes, such as algae and bacteria. Although they were too small to see, these primitive organisms filled the oceans and were some of the earliest life forms on the planet. The mud from this tidal flat eventually transformed into a layer of solid rock, and these ripple marks were preserved in the process. They are now part of the Grand Canyon supergroup. After climbing out of the inner gorge, you'll find yourself on a broad, sun-baked slope. The plants and animals here are well adapted for life with little water. Black-throated sparrows can go for long periods without taking a drink. Many creatures sleep during the heat of the day. Pocket mice forage at night and are preyed on by owls and rattlesnakes, who are adapted for hunting in the dark. These animals are living on the rock layer called the Bright Angel Shale, which formed more than 200 million years after the Grand Canyon supergroup. Trilobite fossils in the rocks tell us that this spot, there's a fossil right there, once lay beneath the sea. This is Grand Canyon 515 million years ago. By this time in Earth's history, many multicellular plants and animals had evolved. Soft-bodied jellyfish floated above clam-like brachiopods and tiny hyoliths, some of the first creatures on Earth with shells. Trilobites, the first animals known to have had eyes, roamed the sea floor. Around them, worm-like creatures burrowed in the sediment that eventually transformed into the Bright Angel Shale. Towering over the Bright Angel Shale is a massive cliff called the Red Wall limestone. The Red Wall has many inaccessible caves that provide nesting spots for one of the rarest birds in the world, the California condor. With a 9-foot wingspan and weighing as much as 23 pounds, the condor is the largest land bird in North America. Condors are vultures, and during the Ice Age, they fed on the carcasses of megabeasts like giant ground sloths. Since then, their population has declined due to changes in climate and human activity, and now they are close to extinction. So down here, it shows you the sea covered the Grand Canyon region many times in the past. As the sea level rose, layers of sediment composed of sand, mud, and shells piled up. Erosion brings sediment to the sea level rises, the sediment layers accumulate. The sediment was compacted and cemented together over time and became sedimentary rock. Different types of sediment became different types of rock. So here are the different layers: shells of marine creatures, mud, sand, all compressed to become limestone, mudstone and shale, and sandstone. Above the Red Wall cliff is a slope of rust-colored red rock. The climate here is not as hot and dry as below, and pinyon pines and Utah junipers are common. Many creatures such as squirrels, chipmunks, and wood rats eat their seeds. These small rodents are preyed on by gopher snakes and coyotes. At the top of the slope is the rock layer called the Hermit Formation. Fossils in the Hermit tell us that long ago, this spot was home to huge dragonflies with 8-inch wingspans. This is Grand Canyon 280 million years ago. By this time, life was flourishing on land and trees. Ferns, fish, amphibians, and reptiles had evolved. The sea had retreated from the region and rivers flowed across the landscape. Seed ferns and conifers grew along their banks, and amphibians left their tracks in the mud that eventually transformed into the Hermit Formation. Above the red slopes of the Hermit are pale 350-foot cliffs. Bighorn sheep easily navigate their narrow ledges with specially adapted hooves. In the fall mating season, males compete for dominance by smashing into each other with their battering ram horns. These cliffs have been carved from the Coconino sandstone. Fossil footprints in the rock tell us that on this spot 275 million years ago, an early reptile walked across huge windswept dunes. With little water, life here would have been difficult. But the desert wasn't entirely barren. Among the other species that called it home were scorpions, millipedes, and spiders. As the desert wind whipped across the landscape, sand piled up in thin layers. Today, those layers are preserved in the Coconino sandstone as thin, angled surfaces called crossbeds. As you approach the rim of the canyon, the climate becomes cooler and more moist. Vegetation on the sloping Toroweap Formation is more dense than below. Before exiting the canyon, however, there's one more layer to scale, the Kaibab Formation. The Kaibab's limestone cliffs are full of marine fossils that tell us about life here 270 million years ago, when the ocean again covered the land. Fossils in the Kaibab Formation tell of a complex ecosystem. The sea floor was home to sea lilies and bryozoans, sponges, and coral. Trilobites and brachiopods lived alongside them, while nautiloids and as many as 40 species of shark patrolled the water above them. Many of these creatures, such as coral and brachiopods, had hard shells. When they died, their shells piled up on the seafloor and eventually transformed into the limestone of the Kaibab Formation. If you ascend from the Colorado River to the south rim of the Grand Canyon, you will have climbed nearly 5,000 feet and passed through 3 distinct habitats. Above the rim, you'll find one more. The Ponderosa Pine Forest is home to tassel-eared squirrels, deer, and elk. Bobcats, coyotes, and hawks hunt here, as well as the top predators in the canyon, mountain lions. Because of its great size and depth, Grand Canyon has a wide range of climates and habitats, and species that call the canyon home today survive on ancient rocks that tell us about life here long before there was a canyon. It's taken millions of years of weathering and erosion to expose these rocks and shape this breathtaking landscape, and these processes continue to this day, relentlessly excavating the grandest canyon on Earth. The grandest canyon. This book depicts a journey across Grand Canyon from the north to the south rim. The mountain lion roughly follows the North Kaibab Trail into the canyon. The girl and her father begin near Phantom Ranch and take the South Kaibab Trail up to the south rim. On their combined journeys, they witness a wide range of habitats and geologic features. Yet, despite traveling roughly 20 miles, descending a vertical mile down and up again, they've only seen a fraction of Grand Canyon. The canyon is simply too big for any one person to see it all, even in a lifetime of study. Its size, however, is just part of what makes Grand Canyon grand. The canyon is mind-bogglingly old, has a rich cultural history, a fascinating ecology, and its geologic significance is second to none. It is the combination of these impressive elements that make it the grandest canyon on Earth. Human history. Humans have been visiting and living in the canyon for at least 12,000 years. The earliest people to come to the Grand Canyon region hunted big game with stone-tipped spears and lived a nomadic life. Later, several different cultures settled in and around the canyon, including the ancestral Puebloans, farmers and skilled potters who lived in multi-room buildings called pueblos. Today's Hopi and Zuni peoples trace their heritage to the ancestral Puebloans. It wasn't until Hopi guides led Spanish explorers to the South Rim in 1540 that the first Europeans saw Grand Canyon. In 1869, the explorer and geologist John Wesley Powell led an expedition down the Colorado River and through the Grand Canyon by boat. It was a perilous journey, and news of his success spread far and wide. In the years that followed, many more people came to Grand Canyon, including geologists, surveyors, miners, artists, and tourists. In 1919, President Woodrow Wilson signed the bill into law that established Grand Canyon National Park. And today, more than 4 million people visit the park each year. The park covers more than 1 million acres of land, and most of the canyon lies inside the park boundary, while parts of it are within the borders of the Hualapai, Havasupai, and Navajo Indian reservations. The canyon remains a place of cultural and spiritual importance for many Native American tribes, including the Hopi, Navajo, Zuni, Paiute, Apache, Hualapai, and Havasupai. Grand Canyon ecology. Grand Canyon is home to thousands of species, including 373 birds, 92 mammals, 1,750 plants, and more than 8,000 invertebrates. 29 species are endemic to the canyon, meaning they don't live anywhere else on Earth. This wide variety of life is due to the canyon's topography or physical structure. Its rugged landscape, and in particular its great depth, have a significant effect on climate throughout the canyon. The lower the elevation, the hotter and drier the canyon becomes. Because of the variation in climate, specific groups of plants and animals called ecological communities live at different elevations, and these communities can be very different. Hiking into the canyon has been compared to walking from the forests of Canada to the deserts of Mexico in a matter of hours. Prominent ecological communities in Grand Canyon. Elevations are approximate. Communities usually transition gradually from one to the next and may be found outside the listed range. The boreal forest, above 8,200 feet. Boreal, or northern forests of spruce and fir, grow on the canyon's north rim only, because the north rim is about 1,000 feet higher than the south rim. Ponderosa pine forests, 7,000 to 8,200 feet. Ponderosa pine forests are found on both rims and in some places below the rim of the canyon. Pinyon juniper woodland, 4,000 to 7,000 feet. Pinyon pines and Utah junipers are drought-tolerant trees and anchor this desert woodland community. Desert scrub, below 4,000 feet. Species from the 3 deserts that border the canyon are found in Grand Canyon: the Great Basin Desert to the north, the Mojave to the west, and the Sonoran to the south. Riparian, along rivers and streams at all elevations. Riparian communities surround and depend on flowing water, such as rivers and streams. They have the greatest wildlife diversity of all habitats in the canyon. Grand Canyon geology. Grand Canyon has one of the most remarkable sequences of rock layers found anywhere in the world. The age of its rocks span more than 1.5 billion years, about 1/3 the age of Earth. And geologists have learned a lot about the deep history of the region from studying these rocks. Each rock layer formed at a different time and in a different environment, and the rocks tell us about these environments. Like detectives, geologists look for clues in the rocks and use them to piece together a picture of the past. Common clues that geologists study are fossils, sedimentary structures, and the type of rock. Sedimentary rock. Most of Grand Canyon's layers are made of sedimentary rock. Sedimentary rock forms when loose sediment is transported, deposited, and then compacted and cemented into solid rock over time. These sedimentary rocks help geologists decipher what the environment was like when the sediment was being deposited. For example, limestone is often made up of the shells of marine creatures, so a limestone layer suggests an ocean environment. Shale, which comes from mud, may suggest a mudflat or a riverbank, and sandstone, which comes from sand, suggests a desert, a river, or a sandy beach. Rock structures. Sediment often retains its structure as it turns to stone, telling us what the surface of the land looked like in the distant past. Raindrop impressions in mudstone record the moment when the rain fell on the muddy earth, while ripple marks tell of an ancient mudflat or riverbeds. Fossils. Almost every layer in Grand Canyon has fossils. The fossils give us a glimpse of ecosystems that existed when the layers formed. Seashells tell us about marine ecosystems, while footprints tell us about terrestrial, on land, environments. Since the layers in Grand Canyon are in sequence from oldest to youngest, they also give us a picture of how life in the region changed over time. The oldest fossils are in the Grand Canyon supergroup rocks, which date from the Precambrian, the period in Earth's history when life first appeared. The fossils in these rocks include stromatolites, structures made by bacteria, and microfossils such as amoeba. Moving up the canyon to younger rocks and forward in time, more complex species start to appear. Trilobites and the burrows of worm-like organisms appear in the layers above the supergroup. Terrestrial species, including reptile tracks, seed ferns, and trees, appear in the Hermit Foundation and the Coconino Sandstone nearer to the top of the canyon. How canyons are carved. Canyons are carved by rivers, but not all rivers carve canyons. To cut a canyon, a river must flow across high terrain and carry sediment in its water. The elevated land gives the river something to carve into, and the higher the elevation, the deeper the canyon can be. The actual carving is done not by river water, but by sediment in the water. As sand, gravel, and most importantly, boulders roll downstream and strike the river bottom, they chip away at the bedrock and deepen the canyon. The more sediment there is and the larger the rocks, the greater the river's ability to deepen its channel. Canyons grow wider as their walls erode and send debris tumbling into their rivers. This added sediment increases the river's cutting ability as it is washed downstream and eventually removed from the canyon. The Colorado River. The Colorado River flows from the Rocky Mountains to the Gulf of California, and on the way, it crosses a broad area of elevated land called the Colorado Plateau. Grand Canyon has been cut into the southwestern edge of the plateau. A lot of sediment washes into the Colorado River from the arid landscape, turning its water rust red, which is how the river got its name. Rio Colorado means Red River in Spanish. In the spring, melting snow from the Rockies floods the river, and with all of that extra water comes more and larger sized sediment. Although flooding in the canyon is now controlled by the Glen Canyon Dam upstream, large floods did rage through Grand Canyon in the past. The dam also traps sediment behind it, so the river is no longer muddy in Grand Canyon. It's thought that the canyon was carved primarily during these floods, and that during prehistoric times, mega floods carried car-sized boulders through the canyon. The river's location on the Colorado Plateau, the availability of sediment, and its annual floods all contributed to the carving of Grand Canyon. Grand mystery. Although the processes that carve canyons are understood, nobody knows exactly how Grand Canyon was carved. In fact, nobody even knows how old Grand Canyon is. Geologists agree that the Colorado River has been running on its present course for 6 to 5 million years. And for a long time, it was thought that the canyon is as old as the river. Recent evidence suggests, however, that the canyon may be much older than the modern Colorado River and that other rivers started carving the canyon before the Colorado. Different geologists have different ideas about the specific details and timeline of the canyon's formation. They actively debate them and are working to uncover new evidence that will support or disprove their ideas. We may never know the full story, but stay tuned. More evidence is bound to turn up and shed new light on the carving of Grand Canyon. The story in the rocks. The layers of rock exposed in the walls of Grand Canyon are stacked in sequence from oldest to youngest. Each layer tells us what the region was like when that layer was deposited, and together they tell us how the region changed over time. Geologists can read the layers like pages in a book, and after years of careful study, they've pieced together the story in the rocks. The story starts at the bottom with the formation of the basement rocks. 5. Grand Canyon is carved. At some point after the uplift of the Colorado Plateau began, Grand Canyon began to be carved. After at least 5 million years of excavation, the canyon now reaches all the way down to the basement rocks. 4. The Colorado Plateau rises. Between 70 and 40 million years ago, tectonic forces lifted up the basement rocks and all the layers on top of them. Today, the uplifted land is known as the Colorado Plateau. 3. Horizontal layers deposited. Eventually, most of the supergroup rocks eroded away. Then, starting 525 million years ago, many rock layers were deposited as the ocean rose and fell, alternately covering and uncovering the land. 2. The supergroup forms and tilts. Starting about 1,250 million years ago, the rock layers of the Grand Canyon supergroup piled up on top of the basement rocks. Then faulting caused the land to break and tilt. This is why the Grand Canyon supergroup layers are at an angle. 1. Birth of the basement. Around 1.75 billion years ago, forces deep within the earth caused an island chain to crash into ancient North America. Heat and pressure from the collision created the basement rocks. A note from the author. As I was researching this book, I tried to imagine how the region changed over time and was bit by the geology bug, as my advisor Wayne Rani put it. Fascinates me that I can look at a rock and with a basic understanding of geology, know something of its past. Now when I look at rocks, I can't help trying to imagine their history, where they came from, and the story of how they formed. This book is my tribute to the canyon and also to the power of the imagination. After all, it's imagination that makes both science and art possible. I hope that this book captures my readers' imaginations, just as Grand Canyon has captured mine. A note on the illustrations. With a few exceptions, my characters travel to places that I went when I visit Grand Canyon. Each illustration in this book depicts a location along specific trails, and if you visit the canyon, you may be able to find the very spots that I included. There are 2 discrepancies, however, that you may notice. The first is that the Shoshone Point Trail, where the characters see the Ponderosa Pine Forest, is not immediately accessible from the top of the South Kaibab Trail. To get from one to the other requires a short car ride. To maintain continuity in the story, I left my character's car out of the book. The second is with the fossils that the girl finds on her hike. They're based on actual fossils that have been found in Grand Canyon, but the real fossils aren't by the side of the trail where she finds them. Some are in collections, others are off the trail or on other trails. To make the story work, I put them where she could easily find them. Where she could easily see them. If you go to Grand Canyon, you may not find fossils where they appear in the book, but there are many fossils to see on trails along the rim and in exhibits in Grand Canyon Village. If you do happen to find a fossil, please leave it where you found it so that others might discover it and so scientists may study it. Collecting fossils or other natural objects inside Grand Canyon National Park is not allowed. Finally, the reader should know that the illustrations of past environments in this book are depictions of what the environments might have looked like. To create them, I worked with Krista Sadler and David Elliott to make each scene as accurate as possible. In each picture, I primarily included species that actually appear as fossils in or near Grand Canyon, with the exception of a few soft-bodied species such as algae and jellies that were likely present but rarely fossilized. For many of the species, there was very little fossil evidence to inform my illustrations. For example, the early reptiles in the Coconino are only known from their tracks. As we don't have any evidence of what their bodies look like, I placed the creature in silhouette. The sharks in the Kaibab are only known from their teeth, but body fossils of related sharks have been found, not in Grand Canyon, so I based my illustrations on those fossils. There are many things, however, that I had to invent entirely, such as atmosphere, light, and color. The images are based on research, but brought to life with my imagination. Jason Chin is the award-winning author and illustrator of Redwoods, Coral Reefs, and Island, A Story of the Galapagos. His book, Gravity, was a Kirkus Best Book of the Year, and his most recent, Water is Water, written by Miranda Paul, was a School Library Journal Best Book of the Year. Jason lives with his wife, author and artist Deirdre Gill, and their 2 children in Vermont. And to close today, I'm going to end with a photo of my own 2 children at the actual Grand Canyon. There they are. And that's Grand Canyon. Thanks for listening, everyone.